So, according to this paper, you already know how to solve these rational equations, do you? Do you already know how to solve these? How do you solve them? Oh, you cross multiply, so you do know how to solve them. So the paper's right, right? Okay. So to solve them, we cross multiply. We say 5x equals 27. Excuse me. And how do you solve for x? Divide by 5, right? Okay. If I divide both sides by 5, be careful, be careful, be careful. What do you get? 27 over 5, right? You don't want to rush. Okay? Now, would it be wrong if I said 5.4? Where did 5.4 come from? 27 divided by 5, right? Okay? Which one of these is more correct? It depends on what you're doing. Okay? It really depends on what you're doing. If it just says solve, which it does, solve, this is a perfectly fine answer. Okay? Now, if we're doing a word problem or something like that, and we need to know how many boogers we picked, we can't really say 27 over 5. That doesn't make any sense. 5.4 boogers makes more sense, right? Okay. Sorry, Marilyn, are you okay? Okay. Is that a little too far? Okay. So let's fill this in real quick. What is the method that we use? Cross multiplication. Okay. Now, what you need to understand that this actually has another name, not a different name, but another name. Can you see that? Cross products. Is that the same or is that different? It's the same, isn't it? Multiplication and products is the same, isn't it? It's a shorter word, okay? Less ink or lead that you have to write, right? Okay. Why does this method work? Let's do B real quick and let's see if we can figure it out, okay? So 4x equals 42. So if I divide both sides by 4, x equals 42 over 4 or 10.5. Okay. Did we figure it out yet? Why does it work? Why does cross multiplication work? Because what I think you understand about cross multiplication is when I have two fractions that are equal to each other, I cross multiply, period. Why? I don't know. That's just what my teachers always told me. That's what I think you understand about cross multiplication. So we have to fix that today if we can. Okay? Let's do this last one and see if that helps at all. Okay? If I cross multiply this, I get 30 times x minus 2 equals 15 times x plus 8. Don't I? Okay? So I get 30x minus 60 equals 15x. 120? Is that right? 15 times 8? You guys have your calculators, don't you? Yeah. Thank you. Okay. So now I subtract 15x from both sides. And I add 60 to both sides. Remember, because we're so amazing, we can do both of those in the same step. You guys remember how amazing we are, right? Okay, just checking. So 15x equals 180, because I put plus and minus. Crazy. 180. So when I divide both sides by 15, x equals 12. Yeah, that's exactly right. 12. Okay, let me show you, because this sentence actually tells you why it works. Okay, so when we use cross multiplication, you're really multiplying both sides by the least common denominator. which we most commonly call LCD. Now, please don't get this confused with LSD. That is something completely different. Okay? Completely different. We're talking about LCD. That's legal to find LCD. Okay? Thank you. Because look, isn't that what's happening? I'm multiplying this side by x minus 2. What'd you say? Oh my gosh, you guys are ridiculous. It's a drug. It's like a hallucinogen type drug. Like you hallucinate when you take it. It's horrible. I actually am very glad that you don't know what LSD is. It makes me very happy. It makes me very happy. Yes. Yes. Okay. So what we're actually doing is multiplying both sides by the least common denominator. Remember back to last week, what would be our common denominator between these two? When in doubt, multiply them together, right? So watch what happens. Watch what happens. If I multiply this side by x minus 2 times x plus 8, what happens to the x plus 8s? That's 1 over 1, right? What am I actually left with? Oh my gosh, 30 times x minus 2. And then I also have to multiply this side by the least common denominator. Oh my gosh, 15 times x plus 8. Now, cross multiplication looks a lot easier than what I just did, right? But that's actually what we're doing. We're actually multiplying both sides by the least common denominator. Okay? So some of them, yes, some of them are as easy as this one. Okay? But because I know where we're going, just go with me for a second. Because I know where we're going, we're not just going to cross multiply here. Okay? So tell me, first of all, what are the restrictions? State any domain restrictions that would make the denominators equal 0. -3? Oh, -3, because -3 plus 3 equals 0, which makes that denominator equal 0. Who is allowed to divide by 0? Only Chuck Norris, and he's not in this class, right? Okay, so, darn it, I know, that would be pretty fun, right? Somebody sent me a picture just on a text message the other day, and it was from Saturday Night Live. And they were talking about the fact that in some country they're like having a contest to name a bridge, and somebody wants to name it Chuck Norris, and he was like, bad idea. Nobody crosses Chuck Norris. And that was really funny. Okay, so we know that x cannot be -3, right? Is there anything else x cannot be? Oh, it can't be what? Oh, +4? Because 4 minus 4 would be 0, right? Okay, so is it okay if we write it like that? Are you okay if we write it like that? I mean, I am. But it is not LSD, it's LCD, okay? How do we find the least common denominator? When in doubt, multiply them together, right? When in doubt, multiply them together. So it's just x plus 3, x minus 4. Now, remember, guys, when we're actually trying to find the least common denominator, we're going to look at all the factors and see if they share any factors in common, and that's going to be part, and anything else that they have that's not shared, that's also part. We'll get there on number 2, but we'll go. I know, it is a mouthful. It's okay. I have a big mouth, so it's fine. Okay? So what we're going to do after we did the domain restrictions, we got that figured out, then we found the least common denominator. Look what we're going to do now. If you have a choice, would you rather work with fractions or without fractions? Without fractions, guess what? Me too. Okay? So we're going to use the LCD, the least common denominator, to get rid of the fractions. Okay? We're going to multiply both sides of the equal sign, or in some cases, every term up here by the least common denominator. So I'm going to say x plus 3 times x minus 4 on that side, or in that term, and x plus 3 and x minus 4 on that side, or with that term. Okay? What happens in this first example? X plus 3 is canceled because I have an x plus 3 divided by x plus 3, that's 1. So all I'm left with is 4 times x minus 4. So 4 times x minus 4 equals. What happens to this term? X minus 4 is canceled. Very good. What am I left with? Excellent. Well, guys, this is just like an Algebra 1 problem now, isn't it? 4x minus 16 equals 7x plus 21. So subtract 4x from both sides. Subtract 21 from both sides. Excuse me. Negative 37 equals 3x. Divide by 3. X equals? Yeah, negative 37 over 3. Is that allowed to be my answer? How do you know yes? And it's not one of my restrictions. Does that make sense? Okay. We could actually like do all the work and get something like x equals negative 3. And guess what happens then? That's not allowed, right? So we'll talk when we get there. All right. So look at number 2. First step, state any domain restrictions that would make the denominators equal to 0. If x were 0, so x cannot be 0. Anything else it cannot be? No, nothing, because really, is there a variable in this one? So then we don't have to worry about that. Okay? What is our least common denominator? 3x. Very, very good. Okay? 3x. Remember, we're talking about factors, right? Okay? So now I multiply each term by 3x. Not just one side or the other, each term. Because really I am multiplying by one side or the other. I'm just already doing the distributive property by multiplying each term by it. Does that make sense? Okay? So what happens here? Yes, the x's cancel. What am I left with? 3. What happens here? The 3's cancel and I'm left with 13x. Excellent. And here? X's cancel equals 21. Oh my goodness, this is even easier than the previous one, isn't it? Say it again. What did I do? Right here? Oh, right here? Uh-huh. Nope, the 3's cancel. One's in the numerator, one's in the denominator. You got it? Okay. If I have 3 divided by 3, that's a 1. So I can simplify that to 1 and it's not there anymore. I'm not. See, here I have an x and here I have x, so I'm canceling those out. So all I have left in the numerator is a 1. In the denominator I have left is a 1. So it's 3 times 1 over 1, and that's just 3. Here I have an x here and an x here. X divided by x is 1. I can simplify that out. All I have left is 7 over 1 times 3. 7 over 1 times 3 is 21. So when I go to simplify the 3's, I have 13 over 1 times x, and that's just 13x. The whole purpose of this is to totally get rid of the fractions. Okay? So I should never have a fraction right here because the way I'm setting it up by multiplying each term by its least common denominator, I should simplify everything in the denominator. If you don't, you have a problem. Okay? Good question. Are we good on 1 and 2? Okay? Look at... Trying to think. It looks like we're going to have time for one more. So which one of these do you want to do? 5? Okay. I figured you would want to do 5. So what do we have to do first? Factor. Okay. So x plus, how about 2 and 3? Does that work? Okay. So what are my restrictions? can't be a negative 2 or negative 3. So that takes care of this one and this one. What about this one? Oh, I already have it written. Do I have to write it again? What about this one? Negative 3. I already have it written. Do I have to write it again? No. Very good. Okay. What's my least common denominator then? You're right. Yeah, x plus 2, x plus 3. So I multiply each term by x plus 2, x plus 3, x plus 2, x plus 3, x plus 2, x plus 3. So after all that mess, what am I left with the first fraction? Yeah, 3. Because look, x plus 2, x plus 2, x plus 3, x plus 3. All that's left is 3. Look here. X plus 2, x plus 2. So what I have is x minus 1, which was what was in the numerator before, and then what was left that did not simplify to 1. Does that make sense? Okay. Equals 7 times x plus 2. Okay. So I have 3 plus x squared plus 3x minus 1x minus 3 equals 7x plus 14. Okay so far? Oh goodness, what kind of problem has this now become? It's a quadratic now, isn't it? Okay, so I need everything to one side and I need to combine all my like terms. Should we do that in 2 separate steps? I think I won't lose you so much. So I have x squared on this side, and I have 3x minus 1x, so plus 2x. Ooh, look at this. 3 minus 3. 0, okay? Now I need to get it equal to 0 because it is a quadratic, correct? So I'm going to subtract 7x from both sides, and I'm going to subtract 14 from both sides. So x squared minus 5x minus 14 equals 0. Factor x minus 7, x plus 2. So x equals 7 and x equals negative 2. What? X equals 7 and x equals negative 2? What?
So it's only x equals 7.
Yeah, this can't be real. Only that one, yeah. Okay, y'all have a good day.